In today's video, we are going to take a detailed look at the assembly and disassembly process of the track system on an ASV RC30 skid loader. Little backstory behind these machines. These ASVs are actually made in northern Minnesota. Back in 2001, I believe, correct me if I'm wrong, I'm sure you guys will, they were 40% owned by Caterpillar. They started off as themselves ASV. Well, then my understanding is Caterpillar needed a track design for their skid loader series because the Bobcat company had already came out with something. So they bought into ASV as a way to get track technology that they could build on, basically. And I believe later on they sold the company back to ASV after, I'm guessing, they got what they wanted. So as you can see, I removed the seat and fuel tank and floorboards to ease the process of replacing some of the hydraulic lines. Due to the fact it took several hours to remove the tracks and get to the drive motor on the left side, which I believe they call the right side in terms of diagram purposes, I figured it was in my best interest to replace all of the questionable hoses. One of the hoses, this one, appeared to be replaced prior to me owning the machine, so the other ones, which all looked similar to this one and in many cases leaking slightly, are getting replaced. I believe there's, on this side of the machine, there's 5 total hoses. I'm going to replace 4 of them, as well as the hydraulic drive motor, which had a failure, which apparently is quite common, that one of these 4 bolts or several will actually break off or strip out. It appears this one was replaced prior to me owning the machine, and this one appears to be the current culprit, which upon failure they appear to dump basically all of your hydraulic fluid almost immediately. It makes a huge mess. I was able to limp the machine into the building because I was not far from my whole building at home, and I began dismantling. But anybody who's had one of these apart is probably aware of how labor intensive it is. So currently I am looking at an option to make a support for this main hydraulic pump, the one that runs all of the hydraulic components, let's just say. So what I've noticed on this machine is that this hydraulic pump, which bolts directly onto the motor, there's not a lot of support. There's a factory brace, which I could try to show it to you. It's back behind, you can see that bolt back there. There's like a little wishbone shaped brace that holds the entire machine up. So what I figured out is that is insufficient. My support actually broke last time I had it apart. Well, it was broke prior, and when I took it apart for a different issue, my whole hydraulic pump in that case was actually loose, and it was just hanging from the motor more or less. And I found that due to a substantial hydraulic leak, and once the hydraulic pump came loose, then it began to leak substantially more just from the flexing of all the hoses and everything. So last time I had this apart, I resolved that issue, and I had to re-weld the support for the hydraulic pump, which appeared had already been replaced prior to me owning. This machine is a RC30, and I purchased it with around 1,500 hours on it, and I believe I'm around 1,540 as we speak. And I purchased it last year. So I'm looking at alternative ways to try to support this hydraulic pump. Currently I have it hanging from or raised up with a ratchet strap, because I've noticed that when I take the skid plate off the bottom of the machine, it seems like these 1.5 hydraulic lines that come off the pump, I think it's actually a supply right from the reservoir is what I think that is, are rubbing on the skid plate, and it seems like every time I take it apart, it seems like they're rubbing more. So I took a ratchet strap, I cranked this thing up a little bit, got it as high as it'll go, because you can, when you crawl under and look, it just looks like it's settled a little bit, and there's a lot of weight hanging out there, so I kind of get it. So I'm going to make a cross member to try to put underneath there to help support that, is what my goal is. I'm not sure if it'll help, but it seems like it should help. My biggest issue is going to be getting clearance on all the hoses to not cause a future leak from rubbing. So I'm looking to have a steel plate put right underneath here, over the top of this, over to the frame rails on each side. So I'm not sure. It's going to be a little bit of a research and development. We'll see in time how it works, or if it works, but it can only help with the situation. Maybe eliminate some future leaks. As you can see, I put colored zip ties on the hoses for the different locations that they go to, because once you get them shoved through the side of the machine underneath the tracks, it's really hard to identify which one's which. So I've been taking pictures along the way in the disassembly process to make sure that I get everything in the right spot. So therefore I'm not looking through diagrams and trying to figure out where everything goes later. I left the larger hoses from the drive motor loose underneath the fuel tank area to allow me more length to work on it, basically, so it's not quite as much of a struggle. So when you're bolting the drive motor back into this, let's call it the sprocket frame, they probably have another term for it, but this bottom one, there's no way to get a wrench on the back of it. I'm not sure if they have a special trick or tool or whatever, but I actually took a screwdriver and shoved it in from this side. It's really hard to see, but it's able to wedge that nut in a way that it can't spin on the back side. It took a couple tries to get it to work, but that's how I got it loose, and seemed to work all right putting it back together, so should work. With much of the larger hardware like these 1/2-inch bolts that hold the drive motor into the frame, I actually went to the local hardware store and picked up some grade 8 replacements, because the ones that I took out were in pretty poor condition. So a couple dollars goes a long way to be able to use some fresh hardware on reinstall. So I've got the drive motor and this frame that it mounts to installed. First time I got ahead of myself and hooked the hydraulic hoses up to the drive motor, but the drive motor actually has to slide through the framework and then the hoses get hooked up, which I should have known better. And then I basically built everything on the floor and then bolted this pin right here, that bolt all the way through, and basically attached it all. The key to the whole thing is making sure the hoses are routed somewhat the way you'd like them, because once it's all bolted together, it's pretty hard to fight those in a different direction. I left the parking brake cylinder right here in a loose position for the time being till I get the sprocket attached. We're getting close to that point here, coming up soon. So this is something I'm going to give a try. I'm not sure if it's going to work yet. If it works out great, maybe I will further elaborate on it. This is going to be a cross brace to hold up the main hydraulic pump underneath the fuel tank. I will show you it when it's fully installed. Basically that hydraulic pump looks like it sags, and I don't know if it's a factory defect or something's tweaked, or I had previous issues with the mounting hardware that actually holds that to the motor in the back failing or coming loose or breaking or some variation of that. And that the bracket that actually holds the hydraulic pump has even broke in the past. So I'm going to try to put this in underneath the hydraulic pump, and just to help support it a little bit. Maybe everything else will work like it should with just a little bit of support. So I wrapped this thing with a rubbery like product, almost like that. Well, the middle part is like a foam weather stripping product, and the outer edge is a rubber product. And then I wrapped that with a stretchy electrical tape, high quality, so it should stay as it is. Basically, the center is to support the pump. The sides is just to keep hydraulic lines from getting wore through, basically. It's kind of a tight area. Doesn't leave a lot of room for options without... I'd rather not get in there with the welder and start welding things. There's a lot of hydraulic fluid that could easily start on fire, so let's not have that. So give it a whirl. So I've got my makeshift support installed underneath there. Hard to really see. I just took some fine thread screws and screwed it down. It's more of a trial run to see how it does, and then if it works great, if we ever have this thing apart again, we may adjust or improve upon that point. I don't know how bad it vibrates underneath there, so that's part of the reason for all of the cushion and tape wrapped around it, so I don't wear through something I'm not supposed to. Little trick that I figured out with the help of some of the web forums online. When it comes time to take this sprocket off, it can be an absolute nightmare. You take this bolt out, well then there's a keyed shaft inside of there. And it's kind of a cone-shaped shaft that the sprocket slides onto. Well, if your sprocket hasn't been off in, let's just say 20 years, it can be quite challenging to get it off. I tried just about everything with no luck. And they do apparently make a special puller to remove it, but they can be a little bit hard to come by and quite expensive. So, little trick that I figured out online. If I remember who gave me this idea, I will try to give them credit. So, this is just a typical wood splitting wedge. Stick that in between the drive motor and the sprocket. Careful not to put it against the shaft. You might have to stagger it at a slight angle to miss the shaft. But literally it took 2 minutes with 2 of these, one from each side, and I had that sprocket popped off. I think I wasted 2 or 3 hours previously trying every other trick in the book and had no luck. So just another possible solution. All right, all of the hoses are hooked up. The sprocket is officially mounted. The center bolt right there is spec'd to be torqued at like 80 pounds. But if there's one thing I figured out online is that unless you have brand new hardware, which I do not, it's kind of it's a special metric fine thread bolt, and then it would be grade 8. Unless you have one of those, which they can be hard to come by. Some of the suppliers may or may not have them. It's hit or miss. In this case, I used my old bolt again, and I used some medium Loctite, just a touch on there. It's not really holding a lot of physical weight. It's just you don't want it to back out. Is pretty much what it comes down to. So I feel pretty confident that with a little dab of medium Loctite, I can get that off if I ever have to, without over tightening it. Because if you break the bolt, you are going to be in a world of problems, because the drive motor that you just replaced, or are going to, well, if you're going to replace it, it's maybe not as big of a deal, but if it breaks off in the new drive motor, you are going to be very unhappy. It's a very expensive part that you don't want to be buying again or rebuilding when it's brand new. So we got that all put back together. We have the parking brake reinstalled, new hardware on that also. I think the hoses are all routed pretty good. I need to add some zip ties and do some little finishing touches on a few things. Everything is put together in here now. Ready to add hydraulic fluid here pretty soon. And hopefully get the fuel tank back in and get ready to start this thing up hopefully soon enough. If you haven't already, now is probably a good time to grease some of the hard to get areas. I believe there's just 3 on the tracks, other than there's one on the outside of the sprocket when it's all finished up, but that's quite accessible. So I would grease those up ahead of time. In case you have a bad greaser, it could be a lot easier to fix right about now. Alright, when it came time to put the bearing back on, I just took a old conduit fitting, 1¼ EMT size. I had one laying around that was missing all the screws, so it really doesn't have much purpose. So I basically I tapped the bearing on lightly with a hammer to get it all the way to the shaft. And you could use a block of wood to get it that far if you'd like. But this 1¼ coupling fits perfectly over the shaft. So then I was able to tap it the rest of the way. Took a little bit of force. I had a 3-pound hammer, but it actually didn't go too bad. Alright, we got pretty much everything put back together. I gotta get some different nuts for this. The original nuts were a shallower nylock, but they are in bad shape. They almost look like they were cut to be that shallow. And the bolts that go through, I had to cut down because I couldn't get the right length, and they have to be that short to get in there unless you put them in there before you assemble everything, which the factory ones are this length, so they must not expect that outcome, I guess. So eventually we get those nuts swapped out. For now I just put a dab of Loctite on them, the medium stuff, just enough to make sure they don't fly off until I get it figured out. Other than that, this part is all assembled, and I started filling it with hydraulic fluid, and I'm going to let it sit for a little bit here and see if we have any leaks. When you're removing and reinstalling the seat, I find it the best way that I came up with, unless you have 2 people, is to use a vice grips to hold the nut that's down underneath the undercarriage. It can be quite challenging at times. I came up with this interesting technique to help support the fuel can, because I'm not sure about you guys, but holding a fuel can up at shoulder height while you fill up the machine is not that great of a deal. When the machine's actually sitting on the tracks, it actually sits perfectly and dumps in at like the perfect angle. But it's jacked up right now, so it'll work for now. Alright, I just got done starting it up for the first time in 2 months. Warmed it up, basically cranked it up a little bit, built up some hydraulic pressure, checked for leaks. I didn't find any leaks, so that's a good thing. I didn't really want to put the track completely back on if there was a major leak somewhere. So it looks good, so I'm going to go ahead and put the track back on. Hopefully nothing occurs later. There is a video that shows this part quite well on the internet. I believe it was created by Track Loader Parts. But I'll give you the quick overview of what worked for me so far. So I actually took the back wheel off instead of the front wheel on the outside for the removal process. Well, and I also took off the 2 wheels right there, which greatly helped with this project. And the one on the back side actually was already missing. Well, I have it. It fell off prior to my issue. And actually the one on the other one on the back side from this middle one of these three is actually loose right now. And I took that loose to get the parking brake bolt out. So I have to re-secure that one, but it's in there, it's just not tight. So I figured out it works great to lube up the track with some WD-40 or something. So you put the front on first, roll it up over the top, and if the tensioner is all the way loose and it's laying on the frame rail like that, sprocket's all the way down, a little bit of WD-40 on the back, you should be able to basically kick it in there. It literally took 5 seconds. So I am going to put the back wheel on and maybe a couple of these other wheels, and I'm going to get it tensioned up and see what we got. There is a couple ways to tension the track. They recommend using either a chain hoist, or you could use a pry bar, or there's other creative techniques. I actually took out the splitting wedges I used to take the sprocket off, and I have one under the pry bar to pry the sprocket up, and the other one I have on a block of wood, and as I pry it up I just keep sliding the top one in, and it looks like we are almost to the point of getting the bolt in, so it's actually not going too bad. Alright, we got all the outer wheels on. I still have the tensioner loose. It's bolted in, but it's not tensioned yet. I have 2 inner wheels to secure, and then we'll be ready for a test run. Alright, we are all buttoned up, and all the bogey wheels are on, and everything's tightened up, and the tensioner is tightened up. Everything is greased. Should be ready to go. Skid plate's back on. I still don't have any leaks, so that's good. This is what the aftermath looks like after everything's all said and done. It requires a wide variety of tools. Let's see, some must-have tools that you're going to need. You're going to need the circlip pliers for taking the little wheels off. In my opinion, you're going to need 1 or 2 of these splitting wedges. I have a 42-inch pry bar. That was a very essential item in this process. Probably some variation of a 2 to 4 pound hammer. Seemed like it got used a lot. Wrenches. You're going to want wrenches from 7/16 all the way up to 1 1/4. Pretty much everything is American. There was a couple of metric bolts, but most of it seemed like it was standard. Sockets. You will need a socket up to 1 1/8. So, I mean, there's a wide variety of sockets from 7/16 all the way up to 1 1/8 size. I don't believe I went any larger than that. Most of them were smaller, but some of the larger bolts were 1 1/8. One of the reasons my shop is in such a disaster of a mess is we've got quite a few things we've been working on lately. One of them is this here solar array that was just completed in the last month. I guess one of the reasons why the skid loader project took so long to get fixed, because I had a lot going on. Just trying to get a few things buttoned up here and hopefully get things all cleaned up and back on track.